Okay, so last video we just finished example 2. The one thing I meant to say, so that's why I came back, was if you picked a bigger scale, if you had done 1 centimeter equals to 10 kilometers, my bet would be that you'd be off by more, right? Because now your diagram's really tiny, half as big as this, and so a little error, even the thickness of your pen, is going to make a bigger difference when your scale's tinier. So please don't go too small. All right, example 1 on, or question 1 on that sheet. I honest to goodness really and truly want you to try it on your own this time. So even if you did example 2 with me at the same time, now I want you to turn this video off and try number 1 and then come back and watch as I do it to make sure that it matches. Okay, so pause me, try number 1 and come back. All right, I'm not actually going to pause though. So in number 1, it says 8 meters, you're going 8 meters, 20 meters, 10 meters. So my scale would probably be let 1 centimeter equal 2 kilometers. That would mean my longest vector would be 10 centimeters long. That's not too bad. Now look at where we're going to put our origin. East-north is the first direction, so you're going east and then north. And then you're going west and north. And then you're going north and east. So you'd better start way the heck down here somewhere, okay? And maybe about mid-page again. So I'm going to start about here. Okay, and my first vector is east 40 degrees north. So with your protractor, measuring from the east, going 40 degrees north. So line it up right on your line. Look at it carefully. Hold your protractor, which I can't because my hand's busy, and east-north. So from the east, go 40 degrees north and put a little mark in. Now take your ruler, and that vector was 8 meters. So for me, it's going to be 4 centimeters long. Okay? So from here to here, 4 centimeters. Right there. Okay, and I'm going to label it 8 meters. And it was east 40 degrees, so my 40 goes in here. I have my arrowhead. And where my arrowhead is, I'm going to make a little XY axis, and that's where my next protractor is going to line up as I do west 20 degrees north. West 20 degrees north. So again, my protractor would run east-west, and from the west, I'm going to go up 20 degrees. Okay, so line it up from the west, go up 20 degrees. And this vector is 20 meters, which means for me, it needs to be 10 centimeters. Okay, so from here, hitting the dot, 10 centimeters. Okay. Right like that. Arrowhead. This is where my next XY axis is going to be. So while I'm over here, just going to draw it in. I need to label this. This is 20 meters. And this angle right here, I think it was 20. Were they both 20? Yeah, and this is 20 degrees. Okay, my third angle is north 30 degrees east. So from the north, from up here, I'm going to measure down 30 degrees. So line your protractor up with the tip from the north, come down 30 degrees. I think that's what it was. Yeah. Okay, this one needs to be 10 meters long, which for me will be 5 centimeters because of my scale. I'm just going to back it up and go from 1 to 6 so I have enough spot. Okay, so from here to there. Arrowhead, this is 10 meters, and this angle in here is 30 degrees, and I have an arrowhead on. So I've now finished the 3. It says draw a labeled scale diagram. And what is the ball's displacement? So we need to put the displacement in. So start where the first one started, end where the last one ended. And I find it helpful to put the displacement in a different color. Hopefully you find it helpful if I put the displacement in a different color. Put the arrowhead on, always where you end. And now measure its length. And I get its length to be like 11.1. Just going to double check it if only I could see well. Yeah, 11.1 centimeters, but my scale is 1 centimeter equals 2 kilometers. So 11.1 centimeters would be 22.2 kilometers, right? To switch it back to kilometers. Now I need to take my protractor and I need to measure the angle down here. You can measure with whatever part you want. I might measure with the west, just because we haven't recently, okay? So line it back up at the origin, and I'm going to measure off the west, going up to my purple line, and when I do that, I get 70 degrees. So to be square bracket, west, 70 degrees, and then which way did it go? I went north. Okay? So if we look at the questions, A was draw a labeled scale diagram. We did. B says what is the ball's displacement? So this is the answer to B, right here. And then C says describe the ball's path if Steve returns it to Jim. So Steve's up here. Jim's the original guy. So now the ball you want to send the ball back. So instead of going west and north, it's going to go east and south. So always when it's going back, the displacement that should be the same, 22.2 kilometers. And the easiest way to do going back is whatever the first direction is, just use its opposite. So instead of west, east, keep the angle the same, 70 degrees, and instead of north, south, right? So you're up here, and so so instead of ending up, it was west and east to get to there, we're now going to go, west and north to get up here. We're now going to go east and south to get back. So this is part C. All right, so now I want you to try a few for homework. So on page 93, how about numbers 8 and 9? 8 will be a little bit tricky. 9 will be easy. Or maybe, actually, how about if we do number 2 and number 8? How about that? That's probably better. Let's do 2 and 8. Let's finish the one on this sheet. So 2 and then number 8 on page 93. So 2 for homework. All right? And then you also have your assignment to work on. Okay? Very good.